Hello everyone. I am Nageshwar Yadav, second year student from CSC department of SRM University, and we are in the group of four people: Rohit Kumar, Abhinay Pratap Singh, and Jyoti Prajapati. First of all, we'd like to thank Amtex for this opportunity to learn industrial-based home automation project. In this internship, we have covered C programming, C++ programming, introduction to IoT, introduction to embedded system, Arduino Uno, LED, CLCD, ADC, LM35, PWM, Arduino based home automation project. In C programming, we have covered, we have gone through the some data types like int, float, char, and operators like arithmetic, bitwise, logical operator, if-else statements, switch case, and also going for loops. We covered do while, for loops, array, string function, pass by value, call by reference function, and recursion. We have also learned introductions of C++ and OOPS, and going through IoT, we have learned the introductions of IoT. Here, simulation tools used for the project implementation. We have used Arduino IDE, PixLab, Null Emulator, Blink Cloud, and Blink IoT mobile application.
My name is Avnay Pratap, second year CSE student from SRM AP, and here I would like to talk about briefly stimulation object which we used for the project implementation. First of all, I would like to talk about briefly Arduino UNA. Arduino UNA is a microcontroller board which uses a 8 Mega 328 microcontroller. It has 40 input pins, of which 6 are analog input pins and 6 uses as power with microcontroller. The pins operate at 5 volts. It has 16 MHz ceramic resonator and USB connection, a power jack, and ISCP header, a reset button, and USB to serial converter. There is a built LED connection to digital pin 13. When the pin is high, the LED is on. When the pin is low, the LED is off. After that, I would like to talk about embedded system. Embedded system is a main part of our home automation project. What is what is embedded system? Any combination of hardware and software which is intended to be a specific task can be called as embedded systems. Types of embedded systems: standalone, real-time, networked, mobile, GPS. After that, I would like to talk about what is IoT. IoT is Internet of Things, the network of physical objects that certain embedded technology to communicate and interact with their internal, started, or the external environment. Internet of Things is a connected to unique object to internet. It is a it has bidirectional communication. It is large and can share complex data flow. It can be used in utilities, insurance, agriculture, factories, automobiles, transports, consumer, and in many sectors. After that, I will introduce a project. What is our project on what is all about? Our project is home automation, and it is a technological solution that enables automating the bulk of electrical, and technological based tasks within a home. In this project, we will automate three things in the smart home, like garden light control, temperature control, water tank control. Uh, and I will briefly tell about the three things that we are automating. That is garden light control. Garden light control is we have to turn on the garden light at night and turn or when in the morning sunlight automatically. And with the help of this embedded systems, we can switch on the lights in the nights and switch off the lights in the morning and switch on the lights in night automatically. After that, temperature control systems, it will read the temperature from sensor and display the temperature of gauge reads in blink IOTF and on the CLCD. If the temperature moves than 35 degree, the heater is on, then turn off the heater and turn on the cooler. And after that, send notification to blink IOTF and display it on the CLCD. After that, I would like to tell about uh, water tank control. Read the volume of the water in the tank and display it on the gauge bits in blink IOTF and on the CLCD. We have to control the inlet and outlet waves of the tanks using button of the blink IOTF. If the volume of the water in the tank is less than 2000 liter, turn off the inlet waves and send notification to IOTF and display it on the CLCD.
Hi, this is Jyoti. I'm going to explain about the mapping of components of our project. Here in this block diagram, you can see a home, a controller, and a Blink cloud server that is connected to a mobile app. On this Blink cloud server, we are going to upload a source code that will be linked with mobile app. And with this mobile app, you can control all the automations of your home. So moving on forward, we have components of our project, that is LED. LED is light emitting diode. It is used as garden lights and it tells whether it's day or night. If night, it glows, otherwise it will be off. And second, we have LDR. It is called light dependent resistor. It is used to indicate the absence and presence of light and also used to measure the light intensity. Moving on, we have CLCD. That is very important to display the notification and state of the heater or a cooler, whether it's on or off. It shows the notification of 2 or 4 line by 16 or 20 columns. And here we have temperature system. It consists of heater, cooler, and LM35. This LM35 is a temperature sensor with the help of which we can read the temperature from this temperature system. So moving on forward, we have output screenshot where we have shown the different conditions of the components. Here we have a condition that is in which heater is on. So when the heater is on, it is showing that temperature is 32.26. And str underscore r on is showing the state of that heater. It's on. So next we have a condition where cooler is on and temperature is 29.33 and cooler is on, is displayed on CLCD along with temperature. Next, we have a condition where cooler is turned off and the notification is shown on this CLCD and displays the temperature. In next condition, we have cooler turned off. The notification is shown on this CLCD, that is temperature is 2.37 and CO-LR off. Thank you.
This is the Arduino circuit, which consists of LDR light, LDR sensor, LED light, and CLCD display. In the CLCD display, we can see temperature is equal to 27 and volume is equal to 3000. And when we will decrease the LDR sensor resistivity, the light will turn off, indicating the presence of sunlight. And when you will increase the LDR resistivity, the light will automatically turn on, indicating the absence of sunlight. This is the garden light management system. Now we move to the our blink app, which is used to home automation for the cooler and heater. And there is a heater and cooler. When you will click on the heater on, suddenly it will start raising the temperature from 28 to 35 as we have programmed. When it will reach to 35, it will automatically turn off. You will get the notification temperature of 35 Celsius degree, turn off the heater. And when you will click on the cooler on, it will suddenly start falling the temperature, and it will start falling, and it will stay till 18. In the CLCD display, we can see it. When the heater is and cooler both are turned on, then there will be no significant changes in the temperatures. And when you will turn off the cooler, it will start again increasing the temperature, and temperature will increase till 35. And here this fan signifies the working of the cooler and heater. Now we move to the remote water tank capacity manager, and there is an inlet and outlet. When you will click on the outlet, it will start suddenly falling the water level down, which we can see in the CLCD display. And we will when we will click on the on inlet, it will start increasing the water capacity of the tank. If both are on at the same time, then there will be no significant changes in the water level tank, which you can see in the CLCD display. And when there is only inlet wallet on, it will increase the water level capacity till 3000, which we have programmed in the program, which we can see in the CLCD display. And we and we will it will reach the and we will get prior notifications from the app when the water is full. Water inflow has to be disabled, or it has to be enabled. And if suddenly water level falls below the 950, then we can direct on the water inlet will automatically turn on, and it will reach to the maximum capacity 3000. Now here we have come to the conclusion. I have learned the basic C plus programming skills. I have learned various functions which are used in the Arduino IDE. I have got a better understanding in connecting the components of Arduino, and I have learned IoT programming and worked over a project over the home automations. Thank you, the Extremes, once again for providing such an opportunity for us, which had helped us to increase our learning. Thank you.